Okay, so this video we are going to discuss how to use the table in a reverse way, okay, for application questions. Right, so before you go through with this video, you have to make sure that you actually know how to use the table in a reverse way. Okay, so it has been discussed in the previous video, and you have to make sure that you already decide what is the method that you want to use when you want to answer all these questions. Okay, all right, so maybe you can start now. For example 11 and example 12, I will only discuss this example with you. Example 12, please try out on your own. It is quite similar to what we have here. Okay, right. Okay, so if you look at this question, generally what you see is like they are talking about the length of salmon, which is normally distributed. So again, for any kind of normal question, you will always see the keyword here, normal distribution. Okay, so usually when I see it, I will always write out the symbol. X is normally distributed. What is the mean? 32.9. And what is the standard deviation? 2.4 squared. So if you want it to be more detailed, you can write out the definition of X. The definition of X is length of salmon in cm. Also can, right? Okay, then now, what do we want to find out is the value of T such that this is the information that they give you. Okay, so the information given is 31.8 smaller than X, smaller than T is equals to 0.5. So again, if you look at this question itself, it doesn't look like the pattern that we learned before, all the 4 patterns, right? But again, as what I said, sometimes you need to continue to solve it until you get the pattern that we have. Okay, so no matter how, we will start discussing this. Okay, so it is given in X, therefore I need to change it to become Z first. So you need to standardize it. How you standardize it? So you take the value of X minus the mean divided by standard deviation. Okay, the same thing happened for T. So T minus the mean divided by standard deviation equals to 0.5. Okay, so if you press calculator, what do you get here is you will get negative 0.458. So I think I told you before, right? When you want to you want to calculate the value of Z, please keep it until 4 decimal places here. Okay, then Z, and then because you don't know what is the T, so what you can do is you just keep it like this, which is equals to 0.5. Okay, and Z is between 2 value, right? So I think previously I told you also when Z is between 2 value, the standard formula is Z smaller than the value at the back minus Z smaller than the value in front. Both are smaller than. What is the reason? I already told you before in the previous, I don't know which video already now, okay? So in the previous video. Okay, then this is the formula that we have. Right. So if you continue from here, Z smaller than T minus 32.9 divided by 2.4. Okay, minus, right. Then this thing, you can get the probability from the table. You learned it before. Okay, so we learned it before. So if you try to figure out the value, Z smaller than negative 0.458. I'm not going to show you the detail, but I will just roughly tell you the value. So you should get 0.3235. Okay, how you get the 3235 again? Please go and refresh back. Okay, how to get the value from here, from the table. Okay, it's equals to 0.5. Therefore, if you continue further, Z smaller than T minus 32.9 divided by 2.4 is equals to 0.8. 0.8235. Okay, so if you look at this one, you can actually treat this whole thing, t minus 32.9 divided by 2.4 as a. So if you look at the pattern, it is actually z smaller than a equals to 0.8235. Can you see the pattern? Z smaller than a equals to 0.8235. So if you want to draw the table, where should be your a or where should be your t, the whole thing? Your a should be here. A, because the area on the left hand side of a should be 8235. So t minus 32.9 divided by 2.4. Okay, so to get the value, now you can try to get the value from the table, finding it in a reverse way. So you look for 235, look for from the table and get the value. So I'm not going to show you how to find the table anymore because we discussed it in the previous video already. So if you look in a reverse way for 0.8235, the value that you get from the table should be 0.929. Okay, and after that, you need to decide whether is it positive or negative. So from the graph, you can see that it is actually positive. All right, so this whole thing is A. So A equals to positive 0.929. So if you move all the value to the other side, you will get the value of T. So if you didn't do any careless mistake here, you should be able to get T equals to 35.1. So this is how we apply the knowledge that we learned in this video in all this kind of application question. So you will see that you need to apply all the knowledge that you learned before for normal distribution, like how to find the probability for z between two numbers. Okay, how to standardize it first, and then how to find the value for probability for z between two numbers, and also again inclusive of the method that you learned in the previous video where you need to apply the table in a reverse way. Right, so it is like combine everything that you learned before for this example 11. Okay, so again, for example 12, I will leave it for you to try it out because example 12 and 11 are very similar. Okay, right, so I will just leave it for you for example 12. And if you not so sure, right, for example 12, you can also refer to example 9.5 that we learned previously, the method. Okay, in example 9.5 in the previous video. The method, the style is more or less the same, although there's no modulus, okay, but when you want to solve and get the value for these two, they are almost the same like 9.5. Okay, so you can refer to it. The answer that you will get should be C equals to 6.77. Okay, so try it out on your own. I'm not going to show you the detail, okay, of the methods. Okay, so just try it out. Okay, so this is one of the example that we apply the knowledge that we learned before in this kind of example. Okay, then now we proceed further. Okay, find the value of mu or sigma or both. Okay, so for example 11 and 12, you apply the normal table in a reverse way once. Okay, and then for example 13 and 14, you need to apply the using the normal table in reverse way twice in one particular question. So that means it is slightly harder compared to the previous one. Okay, so again, let us have a look for the question here. Alright, so they are talking about the x is the length of time in minutes, talking about something like is the length of time. Okay, so x has again keyword normal distribution. Can you see it? And here when they tell you it's normal distributed, they didn't tell you what is the value for mean and what is the value of variance. Okay, so no matter how, I will still write it out. Okay, so mean I don't know, variance I also don't know. Okay, never mind. Then it is given that this information. Alright, so first they give me this information, x greater than 30 is equals to 0.1480. Alright, so to apply and use this information given, I will continue the step first. X, you need to change it become Z. So how can you change it become Z? You take the value of X minus the mean, where you don't know the value, divided by standard deviation, where you also don't know the value, equals to 0.1480. Okay, so if you draw the graph, so it is something like the pattern that we learned just now. Z greater than A equals to 0.1480. So you treat this whole thing as A. Okay? Alright, then now you draw a table, draw a figure here. The center is 0. So you should ask yourself, how can you shape the graph? So the graph should look something like this. Because the area on the right hand side of the value is small. Therefore, it should be 30 minus mu divided by sigma here. Okay, all right. So now try to find out the value from the table. Okay, so 0.1480 does not exist in the table. So you need to take 1 minus 0.1480. Again, all the details I'm not going to tell you anymore. Refer back to the previous video if let's say you forget how to apply it. Okay, then from the table, if let's say you didn't do any careless mistake, you should get 30 minus mu over sigma should be equals to 1.045. Okay, so you should get this value 1.045, and then 30 minus sigma minus mu should be 1.045 sigma. And to make my calculation easier later, I will make mu as the main subject or object. All right. Okay, so and now you have the first equation. So this first equation not enough to find the mu and sigma. Of course, you need to form the second equation. So where can you form the second equation? So if you further reading the question, so you see that they give you another information. Okay, so the second information given is x greater than 20.9 is equals to 0.6228. Again, first step, standardize it. So 20.9 minus the mean, I don't know what is the mean, divided by sigma, standard deviation, and therefore you get 0.6228. Okay, you need to draw a graph because this is a pattern that Z greater than A equals to 6228. So where should be your A? If you didn't draw it wrongly, your A should be on the left-hand side of 0. Okay, so this is the value. This is a graph that you have. Alright, then once you have the graph already, okay, then again, you can find out the value by using the table in a reverse way. So if you apply the method that I teach you before correctly, then the value that you get from the table, it should be 0.313. Straight away find out from the table, it should be 0.313. But if you look at the figure and diagram that you draw, this value is before 0. That means it should be a negative value. Therefore, you should put negative 0.313 here. Okay, then 20.9 minus mean equals to negative 0.313 sigma. Again, I put mu as the main object. So you'll get the second equation here. So I think very obvious already. To get the mu and also the sigma, you need to solve these two equations simultaneously, which I'm not going to show you in detail. So solve 1 and 2 together, and you get the answer mu, which is 23, and also the sigma, which is 6.70. So these two are the answers that you should get if you solve the equation simultaneously. Okay, so for this example, you can see that we are applying the table, using the table in reverse way twice in one particular question. And after that, you can get the and sigma from these two equations. Okay, all right. So again, the same thing applies for example 14. So 13 is an example for you to read. So just make sure that you know how to apply all this. Okay, how to find all these value correctly. Okay, so again, for me, I'm using purely the graph to help me. If you don't use the graph, then you can use formula and make sure you know how to apply it correctly also. Okay, right. Then now, example 14, I'll leave it for you. Okay, so it's quite simple for this question. Okay, maybe I can start forming something for you first before you answer it. Okay, so again, you will see the keyword normal distribution. And then on average, 8 children out of 10 can jump a height for more than 127. So you can actually have a look what is the x here. You can define x as the height. Okay, so now 8 out of 10 students or 10 children can jump a height. The height is x more than 127. What is the percentage? 8 out of 10. That means 0.8. So you can continue, okay, change it become x, and then you form the first equation. And then after that, and one child out of 3 can jump a height of more than 135. So for the second equation, when you form it, it should be x more than 135 is equals to 1 out of 3. So it's 1 over 3. Okay, so what I want to remind you here is, what is the value that should I take when I have 1 over 3? Okay, so please take note, this is our, because 1 over 3 is 0.33333333, right? Okay, then now, this is probability. So if you find out the probability from the table, it is in 4 decimal places. Therefore, when you want to find out in a reverse way, you should keep it to 4 decimal places as well, because this is something outside. What I say is inside, before is 3 decimal places, and then for the probability side that you get, it should be 4 decimal places. So you cannot keep it as 0.3. Later your answer will be wrong. Okay, you have to keep it until 4 decimal places. So this is again another small details that you should know. Right, so again, the value inside here, when you standardize it, is up to 3 decimal places. And when you want to simplify the value outside, okay, it should be 4 decimal places. So 1 over 3, you should keep it as 0.3333. If you put 0.333 also wrong, 0.33 also wrong. Okay, then from here you form the second equation. Alright, so end up, what is the answer that you should get? Mean you should get 132. If you round it off, become 3 significant figure, and the sigma that you get should be 6.2. Okay, so this example, I'll keep it for you yourself to solve it. If you face any problem, you let me know again. Alright, okay, so that's all for this video.